equations a lot. We already solved quadratics. We've already been doing factoring and solving. But this is just broadening it to more polynomials, cubics, quartics. We're going to be able to solve them by factoring, like we know how to factor, by our quadratic formula, and by two new factoring methods that we're going to talk about today. The first one is sometimes referred to as the SOAP method. The SOAP method is used for the sum and difference of cubes. So think about cubes. 1 cubed. 1 times 1 times 1 is 1. 2 cubed is 2 times 2 times 2, 8. What's 3 cubed? 27. 4 cubed? 64. 5 cubed? 125. Now, of course, these are not going to be on the top of your head quite as easily as the perfect squares will be. But those cubes, 1 through 5 especially, those should become pretty easy for you to recall once you're working with these sums and differences of cubes. So when you have a sum or difference of cubes, you've got two perfect cubes, and then either they're being added or subtracted, sum or difference. You can see there the general cases. You have a cubed plus b cubed. That is separated into a plus b, and then a squared minus ab plus b squared. That looks like a lot, but we're going to break it apart. We're going to break it down to make it a lot easier. The reason this is called the SOAP method is because SOAP tells you what signs to use. As you can see, you have 1, 2, 3 signs in these factored forms. No matter if it's the sum or the difference of cubes, you have 3 signs. SOAP tells you first you use the same sign, then you use the opposite sign, and then your sign is always positive. So I have this written again for you in a little bit of a different way. Instead of using A's and B's, we have the first same sign, then the second term. First, same sign, second term. First term squared, opposite sign. First times the second, always positive sign, and then the second squared. Let's try an example. X cubed minus 8. X cubed is a perfect cube, 8 is a perfect cube. So whenever you're defining your A and your B values, or your first and your second value, you take the cube root. You think, where did this number come from? What value cubed gave me this? So what value cubed would give you x cubed? Just regular old x. What value cubed, what number cubed gives you 8? 2. Okay, so those are your first and your second terms, or your A and your B values. So what you do is first you set up a binomial. Your first value, the same sign, and then your second value. Then we take the first value squared, opposite sign, your first times your second, 2 times x is 2x, always positive, second term squared, 2 squared is 4. That is your factored form. So I'm just following this little sequence, and SOAP, same sign, opposite sign, always positive. Now you can compare number 1 to number 2. Number 2 is the exact same numbers, except this time it's the sum of cubes instead of the difference of cubes. So think about your A and your B value, or your first and your second terms. The cube root of x cubed X cubed is x. The cubed root of 8 is 2. So I'm going to take my first term, which is the x, same sign, second term, x plus 2, times the first term squared, so that's my x squared. My next sign is opposite, so that's going to be minus. First times your second term, 2x. Always positive. Second number squared. So you should notice they look very similar, just with the difference of their signs. Let's try some other examples. So we have x cubed plus 27. X cubed is a perfect square, 27 is a perfect square. Think about where those numbers came from. What's the cubed root of x cubed? Just an x. What's the cubed root of 27? Or think in your mind, what number cubed is 27? 3. So you take your first number, same sign, and your second number. Your first number squared. Opposite sign. First times your second number. And then your second number squared. And that is always positive. You guys try number 4. Good, Cody. Good, Jack. Good, Jordan. Good. Good, good, good. Good job, guys. Show of hands, who got that? Awesome, good job. What do you think we need to do for number 5? Cody? That's right. Once we do that, we have y cubed minus 64 equals 0. So now we have the difference of cubes. My a value, or my first term, would just be y. The b value, or my second number, would just be the square root of, or the cubed root of 64, which is 4. Can somebody tell me the answer? Jordan?
Y plus 4.
What's your sign? Same sign. Yes, and you want to use this minus sign after we set it equal to 0. Okay, x minus 4, good. That's all right. Opposite sign. 16, good.
I have 16.
Plus 16. Same sign, opposite sign, then always positive. Now, we have, in number 6, we've got the difference of cubes. Even though there's a coefficient there in front of the x cubed, that's a perfect cube. 8 is a perfect cube. What's the a value here? Or what's the first term? Cameron? Awesome. Yes, you just take the cubed root of that whole 8x cubed. It would be 2x. What's the cubed root of 1,000? You 10? 10, yes. So now we have our first term, same sign, second term. First term squared. What do you guys think? Not quite. The whole first term squared. Jordan?
4.
Yes. 4x squared. You have to square everything. 4x squared, opposite sign, that's going to be plus. What's my first times my second term? 2x times 10 is 20x. Always positive, my second term squared, 100. Okay, now we only have a few minutes left, but it's not going to take very long to explain what we do when we're factoring quartics. When you're factoring quartic trinomials, it's just like factoring quadratic trinomials, except this time you have an x squared value. How would we factor this? X squared minus 7x minus 30. You guys have factored like that many, many times. Cameron? Yes, if there was one, but there's no GCF, so what would I do? Opposite of FOIL. Factor. But what would I factor this to? Sid?
X minus 2 times x plus 3.
X minus 10. Good. X minus 10.
I have some questions.
X minus 10 times x plus 3, right? Factors of 30 that give you negative 7. So guess what? If you have x to the 4th minus 7x squared minus 30, you do the same thing. Factors of 30 that are going to give you 7, except this time you have x squared.
Oh, I thought you were Christy, and like you were walking, and it was like still writing, and I got really nervous.
Okay, so that's it. Okay, so what do you guys think for number 7? We've got x to the 4th minus 4x squared minus 45. So we need factors of 45 to give us negative 4. Julius?
X squared, where are we going from minus 4? So minus 9.
Right.
Times x squared plus 5.
Good. It's just like factoring regular trinomials, except this time you have x squared in your set of binomials. Number 8, factors of 24. You, Chen?
2x minus 6
Good.
times 2x plus 4.
Good. And you mean x squared. That's how we want to say that, x squared. But I knew what you meant. Factors of 15 that would give me 8. I can use x squared plus 5 and x squared plus 3. Ooh, there should be a squared there. How about number 10? Ashley.
X squared minus 7, x squared minus 1.
Good. Do we need to do the last two? Nah, you guys are pros.